Good afternoon, everyone. Last month we had Sister Hetherington talk about the bells of St. Stephen's, and she very quickly in the opening address said that it's really not about the bells, it's actually about St. Stephen's. Well, my talk is really not about lighting up Brisbane, it's just about the first lights that came to Brisbane, okay? But also it's about part of the equipment that provided those lights lay buried for 120 years and no one knew it was there, and we discovered it in 2018. So, lights, where do they come from? Back in 1859 you had Faraday, who was known as the father of electricity, and he developed the electric arc lights. And these, as you can see there, used in a lighthouse, so they were very, very bright. Then they continued to develop, and they're using alternating current, AC. And then in 1876, Edison set up an industrial research lab in Menlo Park in New Jersey in the US. Edison realised that he had lots and lots of things on his mind, and so this was the first ever industrial lab. And then in 1879, no pun intended, there's going to be lots of puns this afternoon, a light bulb moment, and Edison developed, didn't invent, but it developed an incandescent electric light bulb in the US, and Joseph Swan in the UK also developed a light bulb. I'll get onto that in a minute, but just back to the arc lights. They were very, very bright. There's a photo of them used to light up the MCG in Melbourne, but in Brisbane they were used, one Queen Street, it probably would have lit up the best part of the Queen Street Mall, just from one end of Queen Street, and they're also used for lighting up the rail yards at Roma Street. So you can understand they weren't particularly good for lighting up a building like that. So the incandescent lights that Edison and Swan developed were a real light bulb moment. The trick was, this bulb's only about 80 years old, but there's a vacuum inside, there's no air inside there at all. They developed a carbon filament, enabled some electricity to go through that, it heated up the carbon, and that produced the light. Now, light in those days, this was brand new, quite obviously, right? And it was measured in candle power, because candles were the most obvious lights in households. So these lights had 16 candle power. I'll tell you later just how much light that actually is. So, how did they come to Brisbane? Well, there was this guy called McIlwaith, and we had a talk about him in the society here a couple of years ago. He was the Premier of Queensland from 1879 to 1883. Went down to Melbourne for a visit and discussions with the government there, saw that their parliament had electric lights, powered by a generator actually on site, came back to Queensland, knew this was very, very innovative, said Queensland's got to have the same. Now luckily, at the same time, the Edison company was in town, because the printery in William Street, near Elizabeth Street there, they were interested in putting lights. So sort of the government printer was a very, very important organisation. So Edison company was there talking to them, and so when McIlwaith came back and said, we want lights at Parliament House as well, the Edison company said, not a problem. Of course we can do that for you. They knew there was going to be more in it, so they signed a contract with the government for both providing lights into the printery and into Parliament House. And part of that deal was to provide 2 dynamos, which this was all direct current. Direct current's the sort of current electricity you get out of batteries, right? And the generators then are typically called dynamos. So 2 30 kilowatt dynamos and 50 of these 16 candle power lights. That was for the contract. So this had the contract with Edison, all right? But you've got to have steam, your sort of generators. So you had Smelly and Company provided a couple of steam engines to generate, to then drive into the dynamos. You had Andrew Petrie, who was a pioneer architect and builder, and he built the power station behind to house all this. And then a company of Alfred Shaw was the agent for Edison, for the Edison company, and he was going to provide the lights for the Parliament. And he was going to provide, part of that was the Edison Street tubes. And that's very, very significant. So this is what the powerhouse looked like. And you've got to start the system by over here, there's a horse and dray. That's how they got wood into the powerhouse, because the boilers here, they were wood fired. So there's someone stoking wood into that fire all the time. That provided steam, like an old steam train if you like, wheels turning, and then belts and pulleys going up. And these were the dynamos over here in a separate room, because where the steam, that was hot and smoky and smelly, electricity, you had to keep it clean. So that's where the dynamos were put. And keep in mind, this is brand new technology. So those wires going from the dynamos there across to a switchboard, that just would have been bare copper. No insulation, nothing, okay? But it was all brand new. So that was built behind the printer. That was the dynamo that was put in there. Now that's the 30 kilowatts. Keep in mind that our generators now are megawatts. I mean, some of these wind turbines, they're 3 megawatts, so 1,000 times the size of that as far as electricity, and that's sitting up the top of a pole, okay? And you can see here, there's a 100 kilowatt generator, and compared to the men there, it's not all that big compared to the generators that you see these days. But that's what was installed behind the printer, 2 of those. So here's a sketch of Brisbane around about this time. And you can actually see the power station there. This is the printer, and there's the power station. And they had to get electricity down to Parliament House, because McIlwraith, the Premier, wanted lights in Parliament House. So how is that going to be done? Well, if you Google it, as you do, this is what you've got here. William Street coming here, you've got the printer and the power station in behind there, and there's the target down there. And that's about a bit under 400 metres going down. So before we go further, let's talk about Thomas Alva Edison. He, born in 47, considered America's greatest inventor, and I'd emphasise entrepreneur, because you can see there he had over 1,000 patents, but his drive was to make money out of that. And that's why he had the Edison company here when McIlwraith was talking. He had companies all around the world. He had lots and lots of products all around the world. And importantly, he developed an electricity system that had dynamos, power stations, lights, and the means to get the electricity from the power station and the dynamos to the lights. And it was fairly obvious in that more and more lights, you couldn't afford to have a generator in every building like they had done in Victoria Parliament. And he was a manufacturer of dynamos, and he knew that those dynamos could easily be made bigger and bigger and bigger. And it also made more sense that sort of, to have lots and lots of buildings with lights, one big centralised dynamo, but then you've got to have a ways and means of getting that electricity from the dynamo to the lights. So he invented the Edison tubes. Now, these tubes, and you'll see more of them, but, oops, oh, yeah, there they are. There they are there, right, looking straight down. And you can see that there's a metal tube. You can see it here, about that diameter. It's nearly 2 inches in diameter. Sometimes they had two conductors, so it was a positive and negative. Sometimes they just wanted more power, so it's still DC, and they had 3 conductors going in there. But the important thing with these is you had the cast iron tube there, wrought iron tube there. You had these copper conductors going down. You had this spacer, and that was made out of a cardboard type material. But then you needed some sort of insulation, because you had electricity going down these copper tubes. That steel, copper conductors rather, that wrought iron steel could conduct electricity, so you had to insulate it. So there was this, from the back, I've watched speakers press the wrong button. I'm doing it again myself. Right, so this compound was made of Trinidad pitch, linseed oil, beeswax and paraffin wax. Right? Now, you'd wonder why. Okay, but as I said, Edison had this research lab because he tinkered. He kept, I know even when developing the bulb, he experimented with all sorts of bamboo, bits of bamboo and everything for the filament until he finally got hold of carbon thread. So he tinkered. So when you think of this insulation, yes, it's got to insulate the electricity from the outer steel tube, but these were designed to be laid in the streets of New York City where the ground freezes. So you couldn't afford to have this insulation freeze, and you had to maintain some flexibility because the tubes were only 20 feet long, about 6 metres, so yeah, maybe here to the wall. And the reason for that length was Edison realised these were going to be laid in the laneways of New York City, and they're going to be brought there on back of a horse and cart. And you couldn't have anything longer to get around the corners in these little laneways in behind the buildings in New York City. So they're about 20 feet long. So this insulation, these tubes, when they put in the ground, they had junction boxes. So you had to allow a little bit of movement there, and in freezing conditions. But then equally, because you've got these junction boxes, when you're actually out on site and you're installing them, you've got to fill the junction boxes with this compound as well. And we're talking the 1880s, the only way they could heat stuff up was with an open fire. So therefore you couldn't afford to have something that would easily ignite and catch fire. So Edison experimented with lots and lots of materials, and he came up the best compound that would provide the right electrical insulation, wouldn't freeze in a New York winter, wouldn't catch fire when they're installing in the street, was a mixture of Trinidad pitch, linseed oil, paraffin wax and beeswax. Go figure. It's unbelievable. But it worked. That's the whole thing. So there's the tubes there. So the first electric light system in the world was in 1881 in Godalming in Surrey. And the generator there was a hydro generator, and it was manufactured by Siemens. And it's a well-known electrical equipment company that's still in existence today, originally based in Germany. And they used both arc lighting and incandescent lights, and it was AC. In the same year, Edison patented his 2-core Edison street tubes, and he also started the Edison Electric Illumination Company because he knew there was going to be a market for this. So in 1882, he installed an electric light system in Holborn in London, in the UK. He had two generators, used his street tubes and provided a first DC distribution system for lighting in London. Now, so 1882 in London, then New York City, then Milan in Italy, then in 1884 in Brisbane. It's even a little bit more ironical than that the tubes that were installed in Brisbane were manufactured in New Jersey in the United States, but they came from London. And the reason for that is Edison Illuminating Company was putting in this installation for street lights, and sort of Siemens had already put some street lights in. And guess what? The gas companies figured they were going to go out of business if all these damn electric lights were coming in, using newfangled things. So the gas companies formed a lobby, petitioned parliamentarians, got an act passed through Parliament that would constrain the distribution systems of the electricity companies. So all of a sudden, there are all these Edison tubes in London and no use for them. In the meantime, Edison Company had done a deal with McElway's government here in Queensland. Boy, do I have a deal for you. And these tubes came from London to Brisbane. But they were manufactured in New Jersey in the first place. So, again, Googling it, what we had was the power station, tubes going down William Street, and then into Parliament House over there. And these were 2-core, so positive and negative. So then, putting these things in the ground. This is brand new technology. It's never been seen or done before, certainly in Australia, and as I said, only a few places in the whole world. So it was tough. People were on a learning curve. Edison Company had an engineer called J.W. Snow. He died. His replacement, Matheson, wasn't well versed in electricity. It was a shambles, and the wiring was condemned. You had the local council providing the trenching, and I mean, these things were only buried 12 inches below the ground. Every 20 feet, 6 metres, you had to have a bigger section for these junction boxes. But that was the government. But after a long 18 months or whatever, they decided to bring in a guy called Edward Barton. He's a consulting engineer. He had actually worked on the Siemens system in the UK as well. So he knew about electricity. And he got the thing up and working such that in 1886 it was finally finished and they switched on the lights. A total of £19,000 in 1880 pounds. Heaven only knows what that's worth these days. It was a lot of money. So Barton, I said Faraday was the father of electricity. Edward Barton is considered the father of electricity in Queensland. So he was consultant to the government, putting in these Edison tubes. After that, he started a company called Barton and White, electrical engineers. They built a little generator in behind the GPO in a laneway called Edison Laneway. It's still there, Google it. Provided lights into the GPO and some adjacent buildings. Then Barton and White was dissolved. He started the Brisbane Electricity Supply Company, which in 1910 morphed into the CEL, the City Electric Light Company. That's where my grandfather and father worked. CEL went through to the 1950s, managed electricity systems throughout southeast Queensland and northern New South Wales. And then in the early 50s, it all changed. So it then became SEA, Southern Electric Authority of Queensland, then CQEB, Southeast Queensland Electricity Board, then Energex, and then today Energy Queensland. So that was all started by Barton. There used to be a monument down behind the printer, and that's no longer there. But he was very, very clever. So anyway, back to our lights. So they're switched on. Now, this photo was taken in 1910, but you can see these lights would have been the ones installed by the Edison Company. These would have been exactly what I've just been talking about. Now, when they were installed, lots of puns, as I said, yeah, there was a lot less hot air in Parliament. But what the parliamentarians did say was the lights were too bright and they couldn't concentrate. The easy solution, just put a bulb around it, a bowl, light shade, and they did that and they loved it. It was fantastic. And it all worked, but keep in mind, I keep emphasising this, I'm sorry, repeating myself, but this was brand new technology. So this is what they had to put up. Don't strike them at. And the bit on the bottom too, right? Doesn't affect your health, won't interfere with your sleep, right? People just had no idea what this would do, right? But true so. So what happened next? Well, Parliament had the two chambers facing George Street, and then they built an extension coming down Alice Street. So that was an L-shaped building, and that needed lights as well. They had installed more and more lights, and so the lights began to fade a bit. So what they did was added an extra tube parallel to the existing one. This was a 3-core tube, like this one here. Hi, Vicky. And what the 3 cores, still DC, so 1 core went to the Legislative Assembly, 1 to the Legislative Council, and the 3rd provided power to the new Alice Street wing. Then they tied the original cores together, and that was the return cable. So you had 3 positives going to 3 different parts of Parliament House, tied together, and 1 negative going back to the generator back up William Street. All worked fabulously until 1920, when it was superseded and forgotten. It's superseded by what? Well, the simple answer was alternating current. It's the stuff we have coming out of our PowerPoints now. And in the 1880s and 90s, you had what was called the battle of the currents. You had Edison, the inventor and the entrepreneur, pushing DC, direct current. That was his business, his inventions. But you had Westinghouse pushing AC, alternating current. And you had Tesla come along as well, and he invented the AC, alternating current, induction motor, which was a relatively cheap motor. So all of a sudden AC could go into industry as well. But the important thing about AC is you can have a transformer. So you can increase the voltage from 110 up to 110,000. Relatively easy. And once you increase the voltage, you reduce the current, and that means there are less losses. If there's less losses, you can transmit it a lot further. And in fact, Westinghouse and Tesla, they built a hydro power station in Niagara Falls and transmitted high voltage to New York City. If you're trying to do the same thing with DC, you can't easily change the voltage. And your only option to get more and more power is to have bigger and bigger cables. There's no other solution to it for DC. So AC won the battle of the currents. But at the same time, as this was happening, you look at 2021, a lot of misinformation was put out around. People were accused of sort of putting up AC systems which will kill people just by them walking underneath it. And there was, anyway, battle of the currents, moving on, right? But Edison may have lost the battle of the currents, but he was remembered, such that 3 days after he died, Hoover mandated, said, all lights in the United States must be turned off for 1 minute as a mark of respect. So how about that? Isn't that held in high esteem? You just can't beat that. I think it's just wonderful. So Edison was still a winner. So back to our Google. What we've got, they were forgotten until 1986, where the Queensland Museum found some bits and pieces of the old powerhouse behind the printery. Then down in Parliament House in 1989, sorry, 20th century now, 1989, they were doing some plumbing work in Parliament House and they found some bits and pieces of the actual tubes. Then there was an excavation in 1992 out on a right angle out in front of the printer. Now, importantly here, I'll jump right to the end, Jim Simmers, long-term member of the society, sitting up the back here, all right? You had Prof. Prentice from Queensland University, and he asked Jim to actually go and find these tubes because they were important. Prentice realised they were important. So you also had Don McKenzie involved and another guy called Brian Beckinsale. I've got him there as the State Electricity Commission, but Jim tells me he was with the transmission part of CQEB. Anyway, in this photo, this is an article written by Jim, who's described as a amateur archaeologist. And that's Jim there, and that's Brian Beckinsale, and that was Don McKenzie from the Queensland Museum. If you want more details about that part of that episode, talk to Jim. He's got the wealth of knowledge that I'm just retelling the story. But anyway, the thing is, the importance of this in 1992 was that they recovered more bits and pieces, and there was a fabulous display put into the Queensland Museum at the time. They had cable detectors, so they could actually find where these cables were down William Street, because that had never been documented. It wasn't shown anywhere. And, importantly, it was then put on to Queensland, to CQEB's drawings. So we recovered some bits and pieces, we knew where they were, and it was recorded, it was documented. It's a good thing in documentation, in engineering, document. So then, 1992, they were forgotten again, until Queen's Wharf development. All right, now, why is that? Well, let's go back to Google. So we've got the powerhouse here, the excavations, 92, finding bits and pieces and everything else. The thing is, Queen's Wharf was going to cover an area from the river up to George Street, all through here. That's the Queen's Wharf development. And even more important than that, they were going to dig up part of William Street. And that's where our tubes were, both 2-core and 3-core tubes. So what was really good here is the developer did the proverbial dial before you dig, right? And that had results because they knew, they were recorded, they were on the drawings. Jim and his team at the time in 92 recorded this. So dial before you dig, yep, we've got these marked on the drawings. Energex contacted Engineering Heritage Group of Engineers Australia, the Institution of Engineers Australia, And active members in 2018 were Jim Simmers, Brian Beckinsale and myself. I joined that group as well. So the importance here is that although museums, and like Australia, and Brisbane rather, had bits and pieces of these tubes as the roadworks had been done and dug up and everything else, here we had an opportunity to get the full 20-foot lengths and the junction boxes. We had continuity of involvement from the 92 deep. If we didn't do it now, they're going to be lost because William Street now is a car park, okay? But then it was going to be a car park and everyone was willing to help. That was a really good thing about this. So that you had the developer of Queen's Wharf, the Destination Brisbane Consortium, they were in 100%. Yep, what can we do? Their contractor, ProBuild, who was pulling down the old executive building, doing the demolition, that sort of thing, they were only too happy to help. Urbis had been engaged as the archaeological subcontractor. You had various state departments involved, Energex, of course, the Royal Historical Societies, whose offices were just down the road in William Street, and of course Engineers Australia. So everyone was very keen to actually get involved and to help. And so this is what the site looked like before we started. And that's the old executive, well, the remains of the executive building there. And you can see 1 William Street down there, Parliamentary Annex and actually Parliament House, okay? So that's what it looked like. And then we started excavating. And as I said, these things were only buried a foot under the ground. You can see there's the tube there. And there's the old printer and commissariat building and everything else. And so we started recovering these tubes. And up close, we had no idea what they're going to look like. And some of them were encrusted. But this is Tina King, a woman who was engaged by Urbis, an archaeological dig. And her words, this was fabulous because her job as an archaeologist in Brisbane is normally looking at old buildings, okay? All of a sudden, she's in a dig. This is what archaeologists should be doing. But she provided a lot of expertise and a lot of help as we went through. It was fabulous. The developer, of course, was pleased to get publicity, good positive publicity and everything else. So you've got, Tim Witherspoon there from the developer, along with Tina and Jackie, not Jackie Trad, Kate Jones, who was the minister at the time. There I am there. But the thing was, we got on the 6 o'clock news, we got the publicity, and it was important to get it out there into the public to say this was very, very important, very, very significant. So the developer certainly helped with that. But when we were actually digging these things up, how did we actually get them out? I mean, they're all joined as a couple of 100 metres long. But they weren't buried all that deep, so we could use electric saws like this and just cut through the tubes as we went. But we also weren't sure just how flexible these things were. Had they been there 120 years, had they now become very, very brittle? Remarkably, they weren't, but we weren't taking any chances. So you can see 5 people there just to lift it one section out. And down the bottom there, you can see these are the frames that ProBuild had built for us. I'll show you more of that in a minute. And overall, in excavating a couple hundred metres, there's remarkable little damage. But getting back to the compound, where there was a little crack, the stuff just oozed out. But overall, there was remarkably, as I said, very, very little damage. When we did have them, we were conscious, though, that this compound would ooze out. And so where we had the end of a tube, we put on what we call heat shrink caps. So it's a special plastic, you slide over the top, you get a little bit of heat from a blower or something like that, and it just shrinks onto it and then seals it so that that compound couldn't escape. And we collected a few of these things. And these are then put into the frames that ProBuild made for us very carefully. Everything's tagged and registered. You could pick those things up by a crane or a forklift or something like that. If you wanted to ship them somewhere, you could easily just box around it. So they were then also stored in Energex's depots. So here's a close-up. What a junction box looked like at the top there when it came out of the ground, all encrusted with stuff over it, but cleaning up with wire brushing and coating it in fish oil. That was the recommendation for the best preservation. And then we actually ended up some good pieces. So there they are there, and quite welcome to come and look at the sample I've got up here as well. Now the junction boxes, just explaining this fairly quickly, that this is for the 2-core. And as I said, you had one of these things every 20 feet, every 6 metres. So you had to allow for some movement. So in there was just a little piece of loop of copper, and that was how the electricity went from one side, one tube to the other, but still provided some flexibility. Similarly, when you wanted to go through a right angle, they just had copper made into a mesh and just sort of went around the corner. Then you put the lid on, and you've got a couple of holes here on the top. That unscrew those, heat up this compound, as I said, open up under an open fire back in the 1880s, pour the compound in and fill that whole cavity full of the compound, and there it was, all done. Easy peasy. And similarly for the 3-core tubes, same sort of thing, same methodology with the little knobs at the top to pour the compound into. So all the samples were tagged and removed to site. Prior to the excavation starting, so something like 2017 or something, Engineers Australia went out worldwide, went to museums anywhere and everywhere. Would anyone be interested in getting some of these Edison tubes? Knowing that sort of these might be exported, we were conscious of the fact that they were of cultural significance. So therefore we had to identify Energex as the owner, and they went through export permits. It was relatively easy to do for these things, but nevertheless we made sure we went through that process. And so we ended up putting some of these 20-foot lengths and junction boxes into Highfields Museum, who've got a very good electricity section. There used to be an electricity museum in Brisbane, couldn't be staffed, etc., etc. Highfields have got it, so some tubes went up there. Museum of Applied Sciences in Sydney, and the Electrical Museum in Tamworth, which, if you're interested in electricity and in Tamworth, go and see it. It's a very, very good museum. But not only that, we sent pieces to Edison Park Museum in New Jersey, the IEEE, which is the Institution of Electrical and Electronic Engineers History Centre, the Smithsonian in Washington, and the Science Museum in London. Now, some of those are actually, because of COVID, have got delayed, but nevertheless, they've all said, yes, we want sections. And not long after this, I was on holidays in London, went and saw the curator at the London Science Museum, which is one of the preeminent science museums in the world. And he said in his 10-year career with the Science Museum, getting these Edison tubes was the most important acquisition he's ever been involved with. It was just wonderful. I mean, yeah, it goes back, these were first installed in London, so it made sense, but still, he was happy. And then we had discussions with the Speaker of Parliament House, since that's what this whole is all about. Very, very enthusiastic. No qualms, yes, we want some. So Parliament House, we do have a full section now. We had a ceremony where we presented one of these to the Speaker, and that is now on display in the Parliamentary Annex in Parliament House. And then, being engineers, we couldn't help ourselves. So a bunch of us got together in a home workshop, and we made about a dozen of these things here. And as I said, one went to the Speaker, one went to the developer, one went to Urbis, and a few things. We've passed them out. Sadly, one didn't go to Jim, so he's just told me that, and so I'm going to try and correct that, okay? But it was a nice way to finish this whole episode, just making these things, and yeah, we're very proud of the end result. Now, getting back to actually what happened, right? It's interesting that you go to Coles or Bunnings and you can get an LED light like this, right? Light bulb like this. One of these is equal to 7 of the bulbs, the same amount of light, 7 of the bulbs that were put in 1880 to 84, 86, but it only used 2.5% of the electricity. So we've moved on a bit. But if you look at a close-air bulb that's like this, down the bottom there it says E, this one says E27. That E stands for Edison screw. Because if you go back to those photos I showed right in the middle of the drawings, Edison invented a screw to screw his light bulbs in. It's still used today in a modern LED light. And that E, and sometimes it actually says ES for Edison screw. So there were lots and lots of people involved over the years. I'd like to thank them all. I better move on to the right slide, haven't I? Lots of people involved in all the various departments and going back to 92. Been a very, very satisfying thing to be involved with, and thank you very much.